There are moments in science when a simple question fractures the certainty of everything we thought we knew. Tonight, that moment begins with a comet that refuses to behave like one. On October 14th, 2025, a test satellite orbiting high above the Earth released a set of results that immediately set the astronomical community on edge. More than 9,000 images, carefully stacked and analyzed, all pointed toward the same impossible conclusion: a bright interstellar object, cataloged as 3I/Atlas, was moving through our solar system, yet it showed no tail, no diffuse cloud of dust, no glowing plume of ice crystals, no sign at all that sunlight was burning material away. In every wavelength, from ultraviolet to visible light, it looked less like a comet and more like a star, a single, precise point of light. That should have been the end of it: a misclassification, a trick of geometry, a glitch in the data. But the next set of observations shattered that comfort. The James Webb Space Telescope, operating thousands of kilometers away in the deep quiet of space, detected something entirely different: water vapor, carbon dioxide, and volatile gases, unmistakable chemical signatures of an active comet shedding material into the void. Two telescopes, both flawless, both state-of-the-art, describing the same object in mutually impossible ways. Scientists tried to reconcile the contradiction. Maybe the dust was too compact, maybe the viewing angle was wrong. But the more they tested, the worse it got. The data held steady, the math refused to bend, and the tail that should have existed simply didn't. And then came another clue, one that shouldn't exist either. Somewhere along its path, the Psyche spacecraft, en route to a metallic asteroid between Mars and Jupiter, might have passed close enough to observe Atlas directly. If those images were ever captured, they could settle the mystery instantly. But months later, nothing. No data, no announcement, no raw frames in any public archive. A silence as deep and deliberate as space itself. What began as a cometary oddity was starting to look like something else entirely: a cover-up, a misclassification, or a discovery that defied the categories of natural science. In this investigation, we're going to follow that trail, from the conflicting telescope readings to the missing spacecraft data, from electromagnetic anomalies to signals echoing across the galaxy. Because Atlas isn't just another visitor from the stars. It may be a clue that our understanding of what drifts between them is dangerously incomplete. We'll explore the physics that should explain it, but don't. We'll test the boundaries of natural models, dust clouds, fragment swarms, charged plasma halos, and we'll ask the question every scientist dreads but can't ignore: what if this object isn't behaving like a comet because it isn't one? At the same time, we'll step back to see how this mystery connects to others: a 44-minute heartbeat pulsing from deep inside our galaxy, a neutrino so powerful it shattered every record in cosmic history, and solar storms sweeping across Earth just as these events unfold. Coincidence or coordination? Over the next chapters, we'll sift through the evidence, the missing data, and the uncomfortable possibilities. We'll hear from astronomers who say it's all an illusion, and from engineers who whisper that it's not. Because somewhere between the numbers, the noise, and the silence lies a truth big enough to rewrite how we see the universe, and perhaps what's watching us from within it. So stay with me, keep your mind open. And remember, when a comet loses its tail, it might be trying to tell us something. Part 1, The Night Without a Tail. It began quietly, the way most revolutions in science do. Not with a discovery shouted from observatories, but with a small inconsistency buried inside a dataset. At 2:17 UTC on the morning of October 14th, 2025, a team working with NASA's Transiting Exoplanet Survey Satellite, better known as TESS, concluded a months-long observation campaign targeting an object officially listed as 3I/Atlas. The mission wasn't designed for comet hunting. TESS was built to find distant planets by measuring the minute dips in starlight as they cross their suns. But its detectors, capable of capturing thousands of high-precision images in a single run, had turned into an unexpected tool for something far stranger. When the data arrived, the analysts expected the familiar signs of an active comet: diffuse halos of dust, a bright coma surrounding the nucleus, and a slender, ghost-like tail stretching away from the sun. Instead, they saw a point of light.
A single, stubborn dot that refused to smear or spread, no matter how the frames were stacked or filtered. For weeks, the team rechecked every calibration file, suspecting a processing error. But the numbers held.
After stacking 9,132 individual exposures, the composite still showed the same result. Atlas had no visible tail. That result, simple and undeniable, broke one of the most fundamental rules of cometary physics. Under normal circumstances, comets are defined by sublimation, the transformation of ice into vapor as sunlight heats the nucleus. That vapor drags dust into space, forming a coma and tail that can stretch millions of kilometers. It's a process so well understood that astronomers can calculate a comet's composition, spin, and history just from the shape of its light. But 3I Atlas was violating the playbook. It reflected sunlight like a solid body. Its radial brightness profile, the way light fades outward from the center, matched a star, not a comet. "It's like watching a fire burn without smoke," one astronomer remarked in a private forum. Either the smoke is invisible, or it isn't a fire. The first leaks came from within the TESS science community. In private Slack channels and encrypted message threads, researchers described an unresolved point source that behaved unreasonably for a comet. Within hours, rumors reached Twitter, then Reddit, where a single post titled "Where's the Tail?" ignited a storm of speculation. The debate was instantaneous and vicious. Was TESS misreading the data because it wasn't designed for faint, diffuse objects? Was this a processing artifact or something genuinely new? And why were all the official accounts, from NASA to the Harvard-Smithsonian Center for Astrophysics, silent? When the public data release dropped, independent astronomers ran their own analysis. The results confirmed what everyone feared. Even with enhanced contrast stretching and deep noise reduction, the coma was nowhere to be found. Then, on the following day, a different image began circulating online, a spectrograph taken by the James Webb Space Telescope weeks earlier. It showed carbon dioxide and water vapor emissions surrounding the same object. The lines were sharp, unmistakable. Webb was detecting a living comet, venting volatile gases into space. Two instruments, two opposite truths. If TESS was right, Atlas was an inert rock masquerading as a comet. If Webb was right, it was shedding gas at a rate no solid body could sustain. Both datasets were impeccable. Both came from machines designed for precision so fine they could detect the gravitational tug of distant worlds. And yet, both described realities that could not coexist. By the third day, headlines broke across major outlets. NASA data conflicts over interstellar visitor. Atlas defies physics. The comet with no tail. Meanwhile, inside the professional community, an unspoken anxiety spread. Astronomers live by calibration. When two gold standard instruments disagree, it's not just an error, it's an existential threat to the data ecosystem itself. If the contradiction couldn't be explained, it would force every researcher who used those instruments to question their own results. The initial explanations were predictable. Some blamed geometry, the possibility that the tail was aligned directly with Earth, hidden in plain sight. Others invoked particle size, suggesting the dust was too coarse to scatter light efficiently. But none of the models fit all the data simultaneously. By late October, the discussion had shifted from curiosity to concern. The test data had been verified independently by multiple teams. The no-tail finding was real. And if that was true, then something about 3I Atlas was operating under physics we didn't yet understand. There are natural explanations for what we're observing. This is not evidence of anything beyond standard cometary behavior. But when pressed for details, the spokesperson declined to elaborate. The webcast cut out 5 minutes early. The recording, when re-uploaded to NASA's public archive, was edited. The Q&A session removed entirely. That silence became its own signal. If nothing was wrong, why edit the record? Across observatories, night after night, telescopes kept turning toward the silent traveler now drifting between Mars and Jupiter. And every night, the same paradox stared back, a comet that refused to be a comet. Something, somewhere, was missing from the picture, an explanation, a data set, a truth. And the next clue, as we'll soon see, was not buried in a telescope on Earth, but in a spacecraft already out there among the stars. Part 2. The Missing Frames. Psyche's Silent Encounter. If the story of 3I/Atlas began with confusion on Earth, its next chapter unfolded in the quiet corridors of interplanetary space. While telescopes argued about what they were seeing, one spacecraft might have already seen everything and stayed silent. Launched in 2023, NASA's Psyche mission was never meant to chase mysteries. Its destination was the metallic asteroid 16 Psyche, a fragment of planetary core orbiting between Mars and Jupiter. But en route to its target, the spacecraft's imaging system, twin cameras designed for optical navigation and mineral mapping, routinely captured calibration frames, sky fields, and occasional opportunistic science targets. In deep space, data is precious. Every photon is a clue. By sheer geometry, there were moments when Psyche's flight path intersected the region of space through which 3I Atlas was passing. For a brief window, hours, maybe days, the interstellar visitor and the spacecraft could have shared the same line of sight. It was the perfect setup for a once-in-a-lifetime observation, high-resolution imaging from a vantage point completely outside Earth's interference, equipped with instruments sensitive enough to resolve faint coma structures invisible to ground-based observatories. But no such images ever appeared. NASA's planetary data system logs every frame downlinked from Psyche's instruments, from full-resolution science images to engineering snapshots. Searches for any file labeled near Atlas's coordinates came up empty. The calibration sequences from that period were missing. The metadata jumped from one time block to another as though several hours of imaging had never been recorded. At first, the gap was written off as a transmission delay, common for deep space missions relying on limited deep space network bandwidth. But as days turned into weeks, the missing frames never surfaced. No press release, no technical bulletin, nothing. In forums frequented by planetary scientists, quiet speculation began. Some engineers pointed out that Psyche's downlink priorities were dominated by navigation data during that window. Others noted that radiation spikes from solar activity might have corrupted stored images before they were transmitted. But a few researchers, particularly those outside NASA's immediate circles, noticed something more peculiar. The mission logs from that same period showed camera activity. The imaging system was powered on. The orientation telemetry placed the spacecraft's line of sight within degrees of Atlas's known position. If it was pointing in the right direction and the cameras were active, what did they see? Freedom of Information Act requests were filed. Some came back empty. Others returned heavily redacted mission activity reports. The redactions were attributed to proprietary mission operations data. But for a publicly funded mission, the phrase raised eyebrows. That data belongs to the taxpayers, said Dr. Evan Morrow, a planetary scientist at Arizona State University who helped design the Psyche cameras. If the spacecraft observed Atlas, there's no technical reason those frames shouldn't be released. Even if the data is noisy, even if it's unremarkable, it should be archived. That's protocol. The absence of those frames quickly gained a name among online observers, the Psyche gap. Independent data analysts started combing through the PDS archives, comparing timestamp sequences from other instruments on board Psyche. They found patterns of file numbering that suggested something had indeed been captured, but later overwritten. The system used a ring buffer, an onboard memory loop that automatically deletes old files as new ones are created. Unless flagged as high priority, calibration frames are temporary. If the Atlas observations weren't marked for retention, they could have been erased without anyone on Earth noticing until it was too late. That's the benign explanation, but not everyone buys it. Among the conspiracy forums that had followed Atlas since the first no-tail announcement, the theory took root that the images had been intentionally suppressed. The reasoning was simple, if unsettling. If Psyche had captured something structured, something non-natural, the images might be too politically volatile to release without verification. It's an easy leap to make, and perhaps too easy. NASA has strict release protocols. Data embargoes are common. Image processing takes time. Yet what made this case stand out was the silence. No acknowledgement, no schedule, no statement confirming or denying that Atlas was ever within Psyche's field of view. And then came another coincidence, the kind that keeps data archivists awake. A solar storm hit around the same period. The first of 4 massive coronal mass ejections launched from the sun that month. It flooded detectors across multiple spacecraft, forcing some to enter safe mode. For missions like Psyche, that meant shutting down instruments, preserving memory, and waiting out the radiation surge. If the Atlas frames were captured during that window, they might have been flagged as corrupted, automatically deleted by onboard fault protection systems. Or, if you prefer the darker interpretation, the CME provided the perfect cover story for deleting inconvenient data. In the absence of answers, the vacuum filled with speculation. Amateur sleuths mapped orbital paths and found that, during the peak observation window, Psyche would have been within 2 million kilometers of the Atlas trajectory, close enough for clear imaging. A few even claimed to spot faint anomalies in the limited starfield frames that were released. Streaks of light too linear to be cosmic rays, too slow to be meteoroids. Most experts dismissed these claims as pareidolia, the human mind's tendency to see patterns in noise. Still, the mystery persisted. Why was the spacecraft that should have had the best view of Atlas the one mission with nothing to show? In the months that followed, NASA's data servers updated again. New calibration sets appeared in the archive. The missing time blocks remained empty. The Psyche gap held. Somewhere out there, if those frames still exist, compressed, mislabeled, or hidden in a data cache awaiting future downlink, they might hold the only true image of 3I Atlas up close. The picture that could finally tell us whether we're looking at a rogue comet, a relic of alien geology, or something that doesn't fit any natural category at all. Until then, we're left with contradictions. A comet that acts like a star, a spacecraft that saw but did not speak, and a silence too precise to be accidental. And as the scientific community began to argue over the missing evidence, a new kind of explanation started to surface, one that would stretch physics to its limit and force astronomers to ask whether the rules themselves were breaking. Part 3. The contradictions between worlds. If there's one thing scientists fear more than the unknown, it's the impossible. And that's exactly what 3I/Atlas became. Not a mystery to be solved, but a contradiction to be endured. By late October 2025, the data landscape surrounding the object had fractured into two incompatible realities. The optical world, defined by TESS and ground-based observatories, saw a point source, a stellar pinprick, bright, sharp, and inert. The infrared world, led by the James Webb Space Telescope and its spectral instruments, detected active chemistry, carbon dioxide, water vapor, hydroxyl radicals. Both were correct. Both were irreconcilable. At first, the argument was procedural. The Webb team insisted their spectra were clear. Molecular emission lines couldn't appear by accident. The TESS analysts countered that a comet releasing that much gas would have to shed dust, and that dust would be visible even in deep stacked imagery. Numbers were exchanged, papers drafted, preprints debated in hushed academic threads. Within days, a pattern emerged. Each instrument was seeing a different side of reality. The reason, at least on paper, came down to what each telescope measures. Webb, working in the infrared, listens to molecules sing, tracing the vibrations of bonds between atoms, sensitive to heat and gas. It doesn't need reflected sunlight to see activity. TESS, on the other hand, operates in optical wavelengths, relying on scattered light, photons bouncing off dust grains. If ATLAS were emitting gas without dust, the two telescopes would see completely different worlds. But that's the catch. In comet physics, gas and dust are inseparable. When ice sublimates, it drags dust into space. No dust means no gas, and vice versa. Yet here was ATLAS, somehow breaking that symmetry. The implications were unnerving. Ground-based telescopes in Chile and Hawaii joined the campaign, reporting flickers of asymmetry, brief bursts of light that appeared and vanished within hours. Nothing consistent, nothing clear. Some researchers suggested pulsing activity, periodic jets firing from the nucleus, turning on and off like a heartbeat. Others thought the bursts were optical noise, caused by atmospheric distortion. Then came the geometry theory. Perhaps we were simply unlucky. If the comet's tail was aligned directly toward or away from Earth, it would be nearly invisible, a slender thread viewed end-on. The idea seemed plausible until models showed that even under perfect alignment, the coma, the diffuse cloud surrounding the nucleus, should still be detectable. But the coma wasn't there either, and so the contradictions deepened. The situation grew stranger when the SPHERE-X mission, another infrared survey, reported elevated carbon dioxide emissions from ATLAS, orders of magnitude higher than any known comet. The gas ratios were off too. CO2 to H2O levels so skewed that standard sublimation models failed completely. It was as if ATLAS was composed of alien ice, chemistry born in another solar system, under conditions no comet from ours had ever experienced. In normal science, such anomalies are refined away with better data. Noise smooths out, models converge. But here, every new observation only widened the gap. The better the instruments got, the more incompatible their results became. The contradiction turned philosophical. If you can't trust your instruments, can you trust your reality? Astronomy has a long history of these moments, the anomalies that won't fit. The discovery of Neptune came from one, so did dark matter. But sometimes, the anomaly doesn't reveal a new planet or force. Sometimes it reveals bias, a blind spot in how we observe. A few cautious voices proposed that possibility. Maybe this wasn't about ATLAS at all. Maybe it was about us. TESS was built for steady light sources, designed to detect small variations across millions of stars. Its processing algorithms suppress extended structures by default. Could it be that its powerful filtering pipeline had inadvertently erased the faint glow of ATLAS's coma? If so, the no-tail result might be an illusion created by the software meant to reveal precision, not subtlety. It was a comforting idea until independent reanalysis of the raw test frames confirmed that the pipeline wasn't the culprit. The coma wasn't filtered out. It genuinely wasn't there. By early November, the debate had hardened into factions. One camp argued for hidden activity, an unusually compact, dense coma invisible to optical instruments but radiating in the infrared. The other began whispering a word that had been avoided in official briefings: artificiality. Not alien ships, not conspiracy headlines, but a subtler possibility. An object with metallic or crystalline surfaces could mimic both sets of signals, reflect light like a point source while radiating heat and releasing trace gases from engineered materials. It sounded absurd until you realized it fit every dataset almost perfectly. When a NASA consultant was asked about the theory on a live stream, he laughed it off. "We're nowhere near that conclusion," he said. "There are plenty of natural explanations left." He was right. But no one could name one that actually worked. Then, quietly, the data logs from radio observatories began to show something else. Small bursts of static aligned with Atlas's predicted position. Weak, irregular, but recurring. Most researchers dismissed them as solar interference. Others weren't so sure. For the first time, the question spread beyond the scientific community into the public. Could Atlas be more than a comet? It was the question everyone wanted to ask, and no one wanted to answer. Because if the contradiction wasn't an error, if it was real, then the universe had just shown us something outside our physics textbooks, and the next set of discoveries would make that possibility even harder to ignore. Part 4. The Timeline and the Silence. What Psyche might have seen. By November 2025, the data war around 3I/Atlas had become a quiet crisis within NASA's internal channels. Teams from TESS, Webb, and the Deep Space Network were running cross-comparisons of raw telemetry to find any trace of a missing variable, an overlooked calibration, a misaligned timestamp, a stray thermal fluctuation that could explain the irreconcilable readings. Nothing worked. The numbers refused to behave. But the focus soon shifted away from telescopes altogether. A few independent analysts began connecting threads that pointed to a single name, Psyche. To the public, the Psyche spacecraft was a success story. NASA's first mission to a metal-rich world, coasting through the asteroid belt en route to its target. To engineers, it was a marvel of autonomous navigation, streaming back sharp, crystalline calibration images of star fields used to refine its orientation. But for data archivists, something didn't line up. Using NASA's own publicly accessible SPICE kernel database, which logs the orbital trajectories of all active spacecraft, an astrophysicist at Caltech named Dr. Lillian Cho noticed an overlap. During the last week of October, Psyche's flight path had crossed within 2.3 million kilometers of Atlas's projected position, well inside the range of its cameras. The spacecraft's geometry and line of sight would have made Atlas an ideal target for a routine calibration exposure. Cho's first assumption was that someone, somewhere, had already taken advantage of the opportunity. But when she searched the Planetary Data System, PDS, for any imagery captured within that timeframe, the archive showed a glaring hole. No files, no metadata, no telemetry tags. Just a silent skip from one timestamp to another. She wasn't the only one to notice. Over the following weeks, others compared Psyche's engineering telemetry logs, which were publicly available in compressed form, to its imaging data. The camera systems were clearly on. Their exposure counters ticked upward during the exact window when Atlas would have been in frame, yet no corresponding image files existed. At first, NASA blamed bandwidth limitations. Psyche, like all deep space missions, had to ration its downlink carefully. The Deep Space Network allocated only a few hours of transmission time per day, and mission planners prioritized navigation and systems health over experimental imaging. It was entirely possible, officials said, that calibration frames were captured but overwritten before they could be transmitted. The explanation sounded reasonable, but it didn't convince everyone. Every image taken by a spacecraft leaves a digital fingerprint, Dr. Cho told a podcast interviewer. Even if the frame is overwritten, the command to capture it is logged. Those logs exist. The system has to know what it did. And if those commands aren't showing up, something's been scrubbed. Around the same time, an internal NASA schedule surfaced through a Freedom of Information Act (FOIA) request. The document confirmed that Psyche's imaging system had undergone a target validation exercise on October 28th, exactly when Atlas was within its observational window. The name of the target field was redacted. The omission ignited the online communities already obsessed with Atlas. Some argued the redaction was routine, a way to obscure navigation data that might expose mission telemetry. Others claimed it was deliberate obfuscation. What did the Psyche team see that couldn't be named? The story deepened when solar data entered the mix. Between October 26th and 31st, the sun erupted in a series of powerful coronal mass ejections, CMEs, bombarding the inner solar system with charged particles. Dozens of spacecraft, including Mars orbiters and the Solar Dynamics Observatory, reported data corruption and brief safe mode triggers. Psyche's logs showed a radiation spike on October 29th, right in the middle of its target validation window. That meant two possibilities. Either the radiation storm corrupted the data before it could be sent back, making it unrecoverable, or the CME served as a convenient blanket explanation for data that was deliberately withheld. Inside NASA, the conversation was reportedly tense. One project scientist, speaking on Background to Scientific American, described the situation as uncomfortable. "We're not hiding anything," they said. But the truth is, nobody wants to be the person who announces another Oumuamua moment without hard evidence. They were referring, of course, to the 2017 interstellar visitor Oumuamua, whose strange acceleration had triggered years of debate about whether it was a rock, an ice shard, or something engineered. The comparison was unavoidable and unwelcome. By early December, the Psyche gap had become a formal item on the agenda of the Planetary Science Advisory Committee. The committee requested a status report on unreleased calibration data. NASA responded that all non-science critical imagery would be archived after mission phase verification, a process that could take up to 18 months. In other words, wait. Meanwhile, a small but growing number of researchers began assembling what they called the Atlas timeline, a reconstruction of every known observation from the first detection to the last recorded data point. The timeline revealed an uncanny rhythm. Every time new information about Atlas surfaced, a corresponding silence followed. When the test data went public, Psyche's logs went dark. When Webb's spectra were published, no follow-up imaging appeared. When independent astronomers reported faint radio bursts from Atlas's direction, NASA issued a press statement emphasizing that all spacecraft are operating nominally. Coincidence? Maybe, but the pattern was becoming too consistent to ignore. As 2025 drew to a close, the silence around Atlas became as telling as the data itself. Whatever Psyche had, or hadn't seen, remained locked behind procedural walls and polite bureaucratic language. For the public, it was a frustration. For the scientific community, it was a wound. Because if the Psyche cameras really had glimpsed Atlas up close, even a single frame could answer every question. Was the object solid or diffuse? Did it have structure? Did it shine or reflect? Did it perhaps look engineered? Those answers, if they exist, are somewhere in the archives. buried among terabytes of data labeled as engineering test frames. And until they surface, the universe holds its breath. Because for the first time since Galileo turned his telescope to the sky, we are looking at something that refuses to look back. Part 5. When the models break, searching for a physical explanation. In science, contradictions are supposed to collapse under scrutiny. When data disagrees, you go back to first principles, rewrite the equations, recheck the calibrations, redo the math until order returns. But by December 2025, 3i Atlas had become the exception. Every attempt to make the data converge only deepened the divide. For the theoretical community, it was a nightmare dressed as a challenge. The astrophysics preprint servers filled with competing explanations, each more desperate than the last. Every model worked beautifully for one instrument's observations and failed catastrophically for another's. Dr. Mara El-Adi, a cometary physicist from the European Space Agency, proposed that Atlas was an ice crystal aggregate, a body composed almost entirely of volatile molecules that sublimated invisibly, producing gas without dust. The model predicted strong infrared emissions like those Webb had seen, but no optical coma. The trouble was, such an object couldn't survive more than a few days near the sun. Atlas had persisted for months. Across the Atlantic, Professor Mark Hahn at Caltech offered a radical alternative. He described Atlas as a non-gravitational object, a fragment of magnetized plasma or frozen hydrogen held together not by gravity but by electromagnetic cohesion. It was an elegant theory until it ran up against TESS's photometric precision. A plasma fragment should flicker wildly, yet Atlas's brightness remained steady within 1 part in 1,000. Every natural mechanism failed on contact with the data. Some blamed measurement contamination. Others blamed cosmic rays. A few even invoked instrumental ghosts, subtle reflections within the telescope optics. But cross-validation between observatories crushed those ideas. Webb, TESS, SphereX, and even small amateur observatories all agreed on Atlas's basic orbital track and luminosity curve. The disagreement wasn't where Atlas was or how bright it was what kind of object it was. Then, in early December, a paper from Japan's Subaru telescope added fuel to the fire. Using adaptive optics, Subaru captured faint polarization data from Atlas's light, patterns suggesting a reflective surface, smoother than any known comet nucleus. The reflectivity hinted at metallic composition, perhaps nickel or something alloyed. A metal comet. The phrase sounded absurd, but it matched one other thing, the Psyche missions target. That connection sparked another wave of speculation. If Atlas shared a composition similar to 16 Psyche, it could explain the spacecraft team's unusual interest, and possibly their silence. Metallic asteroids are rare, but a metallic interstellar object? That would be unprecedented. Yet even this theory had cracks. Metallic reflectors heat rapidly under solar radiation. They glow in infrared. Webb's data did show warmth, but not nearly enough. Either Atlas was made of an exotic material with a thermal emissivity unknown to human science, or something was regulating its temperature. To many scientists, that implication was a bridge too far. "We don't invoke miracles in physics," said Dr. El-Adi during a televised panel. If the data doesn't fit, we're missing a variable, not discovering magic. But a growing minority quietly disagreed. They pointed to the way Atlas's rotation period seemed unnaturally stable. No tumbling, no precession. Even as solar wind and gravity should have twisted its motion, the light curve stayed perfectly constant. "It's almost as if it's being controlled," wrote an anonymous contributor in one internal NASA memo later leaked online. At that point, the official story was already losing control. Journalists began requesting mission logs, only to be told that relevant datasets were under analysis. Independent astronomers organized open-source campaigns, pooling amateur telescope data in real time to reconstruct Atlas's orbit. What they found didn't ease the tension. The object's acceleration deviated slightly, barely measurable, but consistent, with non-gravitational thrust, similar to the unexplained drift once observed in Oumuamua 8 years earlier. Could sunlight pressure alone account for it? Perhaps. But the reflectivity required to produce such acceleration would make Atlas brighter than it appeared. Once again, the numbers circled back to contradiction. As 2025 faded into 2026, even veteran astronomers began to sound uncertain. "We're in a domain where standard models just don't apply," said Dr. Henrik Volkov of the Max Planck Institute. "If Atlas is natural, it's teaching us a new category of object. If it's not, then it's something else entirely." To test that, an international consortium proposed a desperate plan: a rapid response observation sequence using every available telescope across the electromagnetic spectrum, from radio to X-ray, to capture Atlas during its next perihelion pass. But before the plan could be implemented, something else changed first. The signal started, a series of faint radio pulses, periodic, structured, and oddly consistent, began appearing in data from the Allen Telescope Array in California and the Meerkat Array in South Africa. They seemed to originate from the same coordinates as Atlas, but their timing didn't match known astrophysical phenomena. Not quasars, not pulsars, not cosmic background interference. Each pulse came at precise 44-minute intervals. It wasn't strong enough to be communication, not yet, but it was organized. Predictable. Intentional? The astronomy community split in two again, those who called it coincidence and those who called it a clue. Whatever it was, the contradiction between instruments had now evolved into something deeper, a contradiction between nature and intent. The search for a physical explanation had reached its breaking point, and somewhere, far beyond Earth, Atlas kept moving, steady, silent, and bright as ever. Part 6. The 44-minute signal. Echoes from the void. At first, no one wanted to believe it. A periodic signal, repeating every 44 minutes, arriving from the direction of 3I Atlas. It sounded like the stuff of science fiction, the kind of story that ruined reputations. But the pattern was there, buried in the static, and soon it became impossible to dismiss. The discovery came not from NASA or the European Space Agency, but from a cluster of small observatories that had been monitoring Atlas's trajectory since the Psyche controversy began. One of them, the Allen Telescope Array in California, was running an automated search for fast radio bursts when a faint but structured series of pulses appeared. The signal was weak, barely distinguishable from background noise, but its timing was unnervingly precise. A single broadband pulse every 2,640 seconds, repeating with clockwork accuracy. Initially, it was logged as interference. Ground-based radio telescopes are constantly flooded with noise from satellites, aircraft, and atmospheric reflections. But 2 days later, researchers at South Africa's Meerkat Array detected the same pattern at the same interval from the same patch of sky. Coincidence became probability. Probability became data. If it's an instrument glitch, one operator noted, then both hemispheres of Earth glitched in perfect sync. The first analysis was cautious. The pulses showed no message, no modulation, just short, broadband spikes across a wide frequency range, fading in amplitude over time. They didn't resemble any known radio beacon, natural or artificial. Too short for pulses, too broadband for spacecraft, too periodic for random noise. For a week, observatories worldwide tried to triangulate the origin. When the data were finally overlaid on Atlas's predicted orbit, the alignment was almost perfect. The signal didn't come from deep space. It came from within our solar system, tracking alongside Atlas as it approached its next perihelion. That was when the panic began. NASA and ESA both issued near-identical statements. We are aware of reports concerning repeating radio bursts coincident with the trajectory of 3I Atlas. At this time, there is no evidence that these signals are related to the object. The source is under investigation, but the timing of those statements only fueled suspicion. They were released within minutes of each other, using nearly identical phrasing, a coordination that felt rehearsed. And yet, both agencies avoided the key question: were they listening? Within days, the SETI Institute confirmed that they were. Using its own antennas, SETI analysts detected the same 44-minute pattern, confirming that it persisted even as Atlas moved further along its orbital path. But what startled them wasn't just the consistency, it was the drift. Each pulse arrived about 0.3 seconds earlier than predicted, as if the source were subtly accelerating toward the sun. Acceleration meant motion. Motion meant control. Theories erupted. Some proposed that the signal was a natural plasma oscillation generated by the solar wind interacting with magnetic material, possibly explaining Atlas's metallic composition. Others argued it was a reflection phenomenon, a repeating echo of a terrestrial or solar signal bouncing off the object's surface. But the regularity killed those explanations. Even the sun doesn't pulse with metronomic precision. For a brief moment, the world's attention turned skyward. News anchors began using the phrase, the 44-minute signal. Hashtags trended. Talk shows interviewed astrophysicists who struggled to explain something they barely understood. Most scientists refused to speculate, but a few broke rank. Dr. Emil Kostas, a data analyst from Greece, gave a single cryptic interview. We are measuring behavior that resembles synchronization. That's all I'll say. Synchronization? With what? No one could answer. By early January 2026, something even stranger happened. The signal's intensity began to modulate, not in frequency, but in amplitude. Some bursts arrived slightly stronger, others weaker, in a rhythm that resembled binary encoding. Not enough to form language, but enough to hint at structure. Meanwhile, the TESS team continued observing Atlas in optical light, unaware that radio telescopes were picking up its whispers. The object remained a steady point source. No tail, no rotation, no flicker. Only now, its brightness was increasing in a way no model could explain. If it was reflecting sunlight, its albedo would have to be near perfect, closer to a mirror than rock or ice. And mirrors don't generate radio pulses. SETI's internal memo, later leaked online, put it bluntly. We cannot classify this emission under any known astrophysical process. It is either a highly unusual natural phenomenon or a controlled transmission. But the universe, as it often does, refused to answer clearly. When the 44-minute signal abruptly stopped on January 22nd, cutting off mid-sequence, no one could explain why. There was no solar flare, no CME, no atmospheric event that could have blocked it. It simply ended, fading into the background noise as if a switch had been flipped. In the days that followed, telescopes searching for residual radioactivity found nothing. The signal was gone. Atlas continued on its orbit, silent and bright, a point of light gliding through the darkness. But something had changed. A week after the last pulse, the Psyche spacecraft, which had been quiet since the GAP incident, transmitted an unexpected burst of data, compressed engineering files labeled unclassified navigation telemetry. Buried inside were timestamps from October 2025 that matched the earliest detections of the 44-minute signal. No images, no spectra, just logs. Yet the file headers carried a word that no one could explain: sync mode. Was it a software artifact, a placeholder, or something Psyche had switched to in response to an external input? NASA declined to comment. For those who had followed the story from the beginning, it felt like the final twist of the knife. A comet with no tail, a spacecraft with no images, a signal that pulsed like a heartbeat and then went silent. Coincidences? Maybe. But as the world argued over meaning, astronomers noticed one more impossible thing. The trajectory of Atlas had shifted by a fraction of a degree, exactly in the direction of the sun, as if it had made a choice. Part 7. The Resonance Effect. Patterns across the solar system. By late January 2026, the scientific community was split cleanly in two. One half was still clinging to natural explanations, plasma echoes, data noise, coincidence. The other half whispered the word no one wanted to say aloud: synchronization. The 44-minute signal had vanished, but it left ripples. In astronomy, absence often speaks louder than presence. What followed its disappearance wasn't silence, but pattern. Small, consistent disturbances echoing through systems that shouldn't have been connected. It began with the Deep Space Network, stations in Canberra, Madrid, and Goldstone, which track spacecraft across the solar system, started reporting timing irregularities in their telemetry streams. Tiny delays of a few microseconds that repeated every 44 minutes. Not random, not constant, a rhythm. Engineers at JPL assumed it was a synchronization error in their ground clocks, but the offsets didn't align with known drift rates. More disturbingly, they occurred simultaneously at all three sites, across hemispheres and time zones. At first, no one linked it to Atlas. Until someone did. A systems engineer named Kendra Liang, reviewing the logs, noticed that each phase offset coincided with the exact timestamps of the missing pulses from the Atlas signal. When plotted, the delays formed a damped waveform, as if the universe itself were echoing the pulse, but weaker, diffused across space. She called it the resonance effect. The pattern wasn't confined to telemetry. Around the same period, magnetometers aboard several spacecraft, including Juno, Solar Orbiter, and even the Lunar Reconnaissance Orbiter, recorded faint, synchronous fluctuations in magnetic field strength. Not enough to affect systems, but strong enough to register above background noise. Every 44 minutes, solar physicists scrambled to find a cause. A resonance in the solar wind? A harmonized oscillation in interplanetary plasma? But the periodicity didn't fit any known solar process. The sun's natural oscillations occur on timescales of minutes or hours, not exactly 44 minutes. It was too clean, too intentional. You could almost set a clock by it, Liang wrote in her internal report. It's as if something was testing for a response. When her findings leaked, the internet exploded again. Amateur radio operators began scanning for the rhythm, claiming to detect faint harmonics and background noise. YouTube channels uploaded grainy spectrograms showing spikes every 44 minutes. Most of it was fake, but some matched legitimate data from research observatories. The SET Institute issued a statement urging caution. Correlation is not causation. These patterns may arise from systemic interference or terrestrial harmonics. But behind closed doors, they were running cross-correlation analyses with their archived Atlas signals, and the match was nearly perfect. While the world debated meaning, the scientific establishment faced an uncomfortable possibility. Something about Atlas, or whatever was near it, had interacted with the electromagnetic environment of the entire inner solar system. In early February, the Solar Dynamics Observatory added another piece to the puzzle. Its instruments detected subtle periodic variations in the coronal plasma density, again, every 44 minutes. The changes were minuscule, almost indistinguishable from noise, but persistent. If they were real, It meant the sun itself was responding to something. The phenomenon became known simply as the 44 cycle. It wasn't just electromagnetic. Seismographs on Earth, particularly those in ultra-quiet stations in Japan and Greenland, began showing faint oscillations matching the same period. Planetary scientists dismissed them as instrument coincidence until similar signals were found in Mars InSight data logged months earlier but never analyzed in that way. When you lined them all up, Earth's crust, solar plasma, spacecraft telemetry, radio pulses, they sang the same note every 44 minutes. Some saw poetry, others saw danger. At a conference in Geneva, Dr. Henrik Volkov of the Max Planck Institute addressed the growing unease. We may be observing a distributed resonance event triggered by an object with unique electromagnetic properties. Whether natural or artificial, it's coupling with our environment in ways we do not yet comprehend. The words artificial and coupling appeared side by side in a scientific abstract for the first time in decades. The terms spread like wildfire. Governments began to take notice. Intelligence agencies quietly requested access to radio data archives. The U.S. Department of Defense issued classified memoranda regarding non-terrestrial telemetry interference. China's Chang'e 6 lunar mission reported unexplained signal drift, then fell silent for nearly 2 weeks. Something was happening across the entire solar system, and every attempt to study it deepened the mystery. By mid-February, the resonance began to fade, slowly, irregularly, as if receding into background noise. Some believed it was dying out naturally. Others argued it had served its purpose. The last detectable synchronization event occurred on February 17, 2026, recorded simultaneously by 2 independent instruments, the ESA's Solar Orbiter Magnetometer and the venerable Arecibo Successor Array in Puerto Rico. Both logged a final pulse at UTC 034400, precisely 44 minutes after the previous one. And then, nothing. The universe went quiet again. But the effect it left behind was impossible to erase. Atlas's trajectory had shifted slightly closer to the sun. Its velocity, once stable, had increased by a measurable fraction. Too small to alarm planetary defense networks, but enough to confirm that some force, somewhere, had acted upon it. When the data reached the public, one astronomer summarized it best. It's as if something was tuning the solar system, then stopped. The 44-minute signal had vanished, but the resonance it left behind whispered a question no one could answer. Was it trying to communicate or to synchronize? Whatever the answer, the next observation window was approaching, and when Atlas re-emerged from behind the sun's glare, every telescope on Earth would be waiting. Because if the resonance returned, humanity would have to decide, do we keep listening or do we respond? Part 8. The Return of Atlas, the light that shouldn't exist. By March 2026, the world had learned to live with the silence. The 44-minute resonance was gone, the headlines had faded, and the data had settled into archives labeled unconfirmed anomaly. The public had moved on, but inside observatories and control rooms, no one had stopped watching. They couldn't, because 3I Atlas was coming back. After its perihelion passage, when it slipped behind the sun's glare and vanished from every instrument, the object was expected to reappear in early March, dimmer, colder, and predictable. Astronomers prepared to record its return, hoping to finally compare before and after data. What they found, however, defied every model. Atlas came back brighter, not a little brighter. Spectrographic analyses showed its luminosity had increased nearly 4-fold since its last observation. The object that had once glimmered faintly like a cometary nucleus was now shining like a small star, with a light curve so steady it could have been artificial. That was impossible. As an interstellar object swung past the sun, solar heating should have stripped it bare, vaporizing its ices, darkening its surface, dimming its glow. Instead, Atlas had intensified, as if absorbing energy rather than losing it. For the first few nights, ground telescopes questioned their calibrations. But when independent observatories in Chile, Spain, and Australia all confirmed the same result, disbelief turned into quiet alarm. Then came the next surprise. The light wasn't reflected. Spectroscopic data from the Very Large Telescope, VLT, showed that the emissions from Atlas were monochromatic, a single, pure wavelength centered around 656.3 nanometers, the spectral line of hydrogen alpha. That's the color of stars, plasma, and fusion, not comets, not rocks, not anything inert. It was as if something inside Atlas was radiating energy directly, or as if the object had become self-luminous. Astronomers raced to model it. Could solar wind excite hydrogen on its surface? Could magnetic interactions cause fluorescence? The calculations failed. The energy output was too stable, too narrow, too perfect. "You can't get that line shape without containment," said Dr. Lillian Cho in a late-night interview with Science Weekly. Something is regulating the emission, like a resonance cavity, and comets don't have resonance cavities. As her words spread, public interest reignited. News outlets resurrected the Atlas mystery. Documentaries speculated wildly, from alien probes to natural fusion fragments. Governments, meanwhile, were silent. For weeks, the object's position was monitored obsessively. Atlas was now moving on a trajectory slightly inward, threading between Mars and Earth's orbit, a deviation too precise to be caused by random gravitational perturbation. Then, on March 19th, the strangest event yet occurred. The James Webb Space Telescope, conducting infrared scans unrelated to Atlas, picked up a faint ring of heat roughly 12,000 kilometers around the object. The ring was not symmetrical. It pulsed, expanding and contracting every 44 minutes, the exact period of the vanished signal. No one wanted to say it aloud, but everyone saw the same implication. Whatever Atlas had done months earlier, it was repeating. In a closed meeting at the European Southern Observatory, a consensus quietly formed. The resonance never stopped. It merely changed form, moving from radio to light. If true, that meant Atlas was now speaking in photons. The theory gained traction when synchronized fluctuations appeared across multiple optical instruments. The Keck Observatory, Subaru, and Gemini South all recorded minute oscillations in brightness, so regular they could be plotted like a code. Each pulse lasted about 1.2 seconds, spaced precisely 44 minutes apart. "It's the same rhythm," one technician whispered during a live monitoring session. "It's back, but it's shining." NASA remained cautious. In a brief statement, it confirmed anomalous photometric activity consistent with internal resonance phenomena, but insisted there was no evidence of external control or intent. The statement was quickly picked up by every major outlet, mostly for what it didn't say. Behind the scenes, however, analysts at the SETI Institute were already trying to decode the pattern. Using cross-correlation algorithms, they discovered that the light pulses were not random. The timing contained prime number intervals, the same mathematical structure humans might use to signal intelligence. It was the universal fingerprint of intentional design. Within days, a classified briefing circulated among select scientific agencies, summarizing what the public didn't yet know. The pulses weren't just visible light. They had a polarization pattern, rotating slightly with each cycle, as if conveying angular momentum data. Some analysts interpreted it as encoded orientation reference, a kind of spatial map. But a map to what or where? At this point, the tension between science and speculation reached breaking point. The United Nations Office for Outer Space Affairs announced the formation of an observation coordination group, the first formal global response to a celestial event potentially linked to non-natural activity. For the first time in history, humanity had convened a planetary committee to decide how to listen to something that might be listening back. And yet, in observatories across the world, a quieter truth began to sink in. Atlas was no longer an interloper drifting through the solar system. It was stationary, locked in a near-circular orbit between Mars and Earth, defying both gravity and probability. A comet that had arrived from the stars had somehow stopped moving. That night, Dr. Cho stood on the viewing deck of the Paranal Observatory, watching Atlas shimmer red against the void. It was small, barely a star in the eyepiece, yet steady as a heartbeat. She whispered to her assistant, "It's waiting for something." The assistant nodded. Or someone. And somewhere, in the deep stillness of space, 3-Eye Atlas pulsed once more, one clean flash of hydrogen light, bright enough to be seen with the naked eye. Then darkness again. But this time, the whole world was watching. Part 9. Global Reaction, the Age of Listening. The first time Atlas's pulse was visible to the naked eye, the world stopped. Not metaphorically, literally. In cities across the northern hemisphere, people looked up at the same moment, drawn by a faint red glint near Mars that flared and vanished in the span of a heartbeat. It wasn't bright enough to rival a planet, but it was unmistakably there. For centuries, astronomy had been a pursuit of patience, of collecting photons in silence. But that night, the silence itself seemed to have changed. Humanity wasn't just observing anymore, it was being observed back. Within 24 hours, Atlas's reappearance triggered the fastest global coordination of telescopic assets in history. The International Astronomical Union, IAU, issued an emergency bulletin under the codename Atlas Echo, directing every major observatory to point their instruments toward the object. Even civilian facilities, radio dishes, optical telescopes, deep space antennas joined the effort. For once, the world's science agencies weren't competing. They were listening together. The first planetary consensus. The data came in waves. Atlas's pulses were confirmed from over 200 independent locations, all showing the same 44-minute periodicity in the hydrogen alpha band. The amplitude varied slightly by region, but the timing was identical across the globe, to the millisecond. That precision was impossible for a natural emitter. It was synchronized to a standard time reference, one that matched Universal Coordinated Time, the atomic clock baseline used by Earth satellites. "It's talking in our language," one SETI researcher whispered during the first global briefing. "Or at least it understands our clocks." At the United Nations headquarters in New York, the Office for Outer Space Affairs, UNOOSA, convened an emergency session. Representatives from NASA, ESA, Roscosmos, JAXA, CNSA, and the Indian Space Research Organization attended. It was the first time all major spacefaring nations shared real-time data on a single celestial event. The meeting's agenda was simple: decide what to do next. The American delegation urged caution, continue to observe, gather more data, and avoid transmission. The European contingent argued that Atlas's behavior could represent a non-anthropogenic intelligence, and that contact might already be mutual. The Chinese delegation was silent for most of the meeting, then presented a startling revelation. According to their Chang'e 7 lunar relay satellite, Atlas's most recent pulse had included a weak directional echo, a secondary burst timed exactly 8 minutes after the main emission, delayed by the speed of light between Earth and Mars' orbit. That meant one thing. Atlas had sent a pulse, waited, and then emitted another, as if expecting a reply. The room went still. The network awakens outside. Outside the political chambers, the scientific community was undergoing its own transformation.
Astronomers began referring to Atlas not as the object, but as the source. The term stuck, spreading through academic papers and social media alike. For the first time in recorded history, the world had a single scientific obsession.
In universities, students built backyard spectrometers to measure the pulses. Amateur astronomers live-streamed their data. The online public became participants in real time, crowdsourcing measurements to refine Atlas's orbital position. Within a week, global coordination produced a composite light curve so precise that NASA adopted it for official use. It was the largest distributed scientific collaboration in human history, but not everyone welcomed it. Religious institutions issued statements ranging from awe to alarm. Some called Atlas the messenger, others the machine of judgment. Social media fractured into movements. Hashtag the listener, hashtag red pulse, hashtag echo of God. A few extremists even warned that humanity was opening a door it didn't understand. Meanwhile, global communication networks reported unprecedented electromagnetic interference every 44 minutes, perfectly in sync with the pulse. Power grids in Europe and South America briefly fluctuated. GPS systems showed small, repeating timing drifts, always correcting themselves moments later. The world's technologies were vibrating in resonance with Atlas. It's as if the entire electromagnetic spectrum is breathing with it, noted Dr. Emil Costas, who had been studying the earlier radio bursts. We're not just hearing the signal anymore, we're inside it. The shift in orbit. Then, on March 25th, telescopic data revealed another anomaly. Atlas had adjusted its trajectory again, this time by exactly 0.044 astronomical units, the same number embedded in its pulse cycle. It wasn't random. The change placed it into a stable Lagrange resonance between Earth and Mars, a gravitational sweet spot where objects can hover indefinitely with minimal energy expenditure. That maneuver would require active control. The news broke across the world like a shockwave. The first interstellar visitor known to humankind had apparently chosen to remain in the inner solar system. It wasn't a comet anymore. It was a neighbor. Governments scrambled to contain panic. The U.S. Department of Defense issued statements denying any unidentified controlled activity near Earth's orbit. Yet at the same time, classified documents leaked to journalists showing that both NASA and the Pentagon had begun deep space probe simulations, theoretical mission plans to approach Atlas directly. The age of listening. For scientists, the moment was both terrifying and sacred. A threshold had been crossed, not discovery, but awareness. The cosmos had blinked, and humanity had blinked back. Dr. Lillian Cho, who had been among the first to point out Atlas's unnatural stability, summarized it in a single sentence during a live broadcast from the Paranal Observatory. For the first time in our species' history, the universe is not silent. The only question left is, do we? Across the world, telescopes aligned, antennas turned, and humanity held its breath. Every 44 minutes, the red pulse returned, precise and patient, as if waiting for a response. And though no official signal was sent, many swore that in that quiet interval between pulses, they could feel something, a hum, deep and low, like the faint echo of a heartbeat beneath the static of creation. Part 10. The Signal Within. In the first days of April 2026, humanity's instruments became its nervous system. Every radio dish, Every orbital telescope, every antenna from Greenland to the Atacama Desert was tuned to a single frequency band, 656.3 nanometers, the color of Atlas's pulse. For the first time in modern science, no one was trying to observe anything else. The universe was on hold. The red pulse, as the media called it, continued to appear every 44 minutes, steady, unwavering, and increasingly structured. To the naked eye, it was just a faint flash of red, but under high-resolution spectral analysis, the signal was anything but simple. Each emission wasn't a single tone, it was a chord. Inside that narrow hydrogen line, scientists detected secondary subfrequencies, minute modulations in amplitude and phase that repeated in intricate, recursive patterns. When plotted visually, the signal formed fractal geometries, shapes nested within themselves, scaling down infinitely like the folds of a Mandelbrot set. It was mathematics, not random noise, not natural plasma fluctuation, but deliberate structure. The first to notice was a graduate student in Finland, Aino Vartiainen, who had been analyzing the amplitude curves using Fourier transforms. Late one night, she noticed that the harmonics inside each pulse aligned with a repeating sequence: 2, 3, 5, 7, 11, 13, the first prime numbers. She uploaded her findings to a public data repository at 3:14 a.m. By dawn, the world knew. The prime pattern, prime numbers, had long been considered the universal signature of intelligence, a pattern that could only be produced intentionally, the mathematical equivalent of knocking on a door and counting aloud to show awareness. Within hours, SETI, CERN, NASA, and ESA all confirmed the same discovery. The red pulse was encoding prime sequences nested inside its waveform as amplitude peaks. But the signal didn't stop there. Every fourth pulse added another layer, phase modulations that corresponded to geometric ratios, rad2, pi, and e. To mathematicians, it was poetry written in photons. To physicists, it was a message written in the constants of the universe. It's as if whoever or whatever created this understands not just math, but the architecture of reality itself, said Dr. Emil Kostas during an emergency broadcast. They're communicating in the one language that every civilization, everywhere, must know: the laws of nature. The decoding race. Within days, a decentralized network of scientists, cryptographers, and machine learning engineers formed spontaneously online. They called themselves Project Resonance. Their goal: decode the signal. Synchronized spectroscopic feeds from over 300 observatories, the team created a composite dataset of over 10,000 pulses. When fed into AI pattern recognition systems, a strange discovery emerged. Every group of 44 pulses formed a single, complete sequence. The sequence, when converted into binary, produced an image. At first, it was just noise, but when reconstructed over multiple cycles, the image began to coalesce into something hauntingly familiar: a spiral, expanding outward from a central point, an unmistakable reference to the structure of the Milky Way. In the spiral's center, at the coordinates corresponding to Earth's position, a small luminous dot blinked once, then twice, then once again, a pattern repeating across every cycle: 1, 2, 1. To some, it was a marker: you are here. To others, a response: we see you. Internal turbulence. The implications fractured the scientific community. Some argued for caution. If the signal was deliberate communication, sending a reply could expose our exact location to an unknown intelligence. Others countered that our location was already obvious. Any species capable of interstellar navigation would have mapped Earth's radio emissions centuries ago. A heated meeting at NASA Ames ended with a divided vote. No official response, but passive listening would continue indefinitely. The SETI Institute, however, quietly began preparing a transmission anyway, a mathematical reply encoded in hydrogen alpha frequency, matching Atlas's modulation pattern. It would repeat the first 20 prime numbers and include a simple binary grid encoding the solar system's layout. It was never sent, because before Earth could speak, Atlas changed its language again. The shift. On April 12th, the red pulse stopped without warning. For nearly 12 hours, the entire planet held its breath. Scientists feared the phenomenon had ended, that the chance for first contact had slipped through humanity's fingers. Then, at exactly 0444 UTC, Atlas pulsed again, this time not red, but blue. The frequency had shifted upward to 486.1 nanometers, corresponding to hydrogen beta emission. But more astonishingly, the pulse was no longer singular. Instead of one flash, there were three, separated by 2-second intervals, followed by a long pause. Then the same pattern repeated, 3 short, 1 long.
That sequence corresponded to the letter O. It was the simplest signal imaginable, but it was unmistakably deliberate. Around the world, radio telescopes captured the same spectral evolution, red to blue, 1 to 3.
The shift in color wasn't random. It traced a precise energy ratio of 3 to 2, a harmonic resonance long used in acoustic engineering and quantum transitions. To physicists, it meant something profound. Atlas was manipulating hydrogen emission the way humans manipulate sound waves. It wasn't just sending information, it was using physics itself as a carrier of meaning. This is no longer astronomy, Dr. Lillian Cho said in a somber live feed from Paranal. This is dialogue, in the oldest language in existence, light. The fracture. The world divided again. Governments debated secrecy versus disclosure. Scientists debated contact versus silence. Philosophers debated whether communication with something beyond comprehension was truly communication at all. And then came a final twist, small but devastating. In the latest high-resolution images from the James Webb Space Telescope, analysts noticed a faint object emerging near Atlas. A secondary body, smaller, colder, and moving in perfect synchronization. It wasn't debris. It wasn't an asteroid. It was a companion. For the first time, Atlas wasn't alone, and neither were we. Part 11. The Companion. Shadow in the Light. When the first image appeared, no one wanted to believe it. It was the James Webb Space Telescope, again, that captured the frame. A deep-field composite taken during a routine calibration cycle on April 14, 2026. The object, catalogued as 3I Atlas, had always appeared solitary, a pin of red light floating in the Black Sea between Mars and Earth. But now, beside it, there was a faint, cold reflection, a smaller point of light trailing half a degree behind, orbiting in perfect synchrony. The file was quietly uploaded to the NASA archive under the label Spectral Contamination Candidate. Within hours, someone leaked it. By dawn, the image was everywhere. Atlas wasn't alone. The discovery to the untrained eye, the second point seemed insignificant, a dim smudge, barely visible. But to astronomers, it was seismic. Its motion was precisely locked to Atlas, maintaining an angular separation so exact that random coincidence was statistically impossible. Two objects, one bright and hot, the other cold and silent, moving as if bound by an invisible tether. This isn't gravitational coupling, explained Dr. Mara El Addy on a live stream from the European Southern Observatory. The mass ratio is wrong. The companion isn't orbiting Atlas, it's mirroring it. That implies active station keeping. In other words, control. The smaller object, nicknamed Echo by researchers, reflected almost no sunlight. In visible wavelengths, it was nearly invisible. But in the infrared, it glowed faintly at 90 Kelvin, far warmer than interplanetary background radiation. Something inside it was generating heat. Over the following week, telescopes across the world tracked the pair. The results were baffling. While Atlas emitted its predictable hydrogen pulses every 44 minutes, Echo's brightness oscillated at exactly half that interval, one pulse every 22 minutes, always delayed by the same phase shift. Two signals, two rhythms, locked in harmonic resonance. It was as though Atlas were the carrier wave and Echo the modulator, one transmitting power, the other shaping information. The shadow's geometry. When Webb focused its high-resolution instruments on the pair, the data revealed something stranger still. Atlas's light, when passing near Echo, refracted at sharp angular boundaries, as if encountering a structured surface rather than a smooth sphere. Triangular patterns appeared in the diffraction spectra, threefold symmetry repeating across multiple observations. No natural body in the solar system has geometry that precise. "This isn't a rock," Dr. Cho whispered during a press call. "This is architecture." Her statement, broadcast worldwide, became an instant flashpoint. Governments scrambled to control the narrative, insisting the diffraction data could be misinterpreted. But independent verification from the Keck and Subaru observatories confirmed the same geometry. The angles, measured at 60 degrees and 120-degree intervals, were consistent across instruments and wavelengths. Within days, the term the triad pattern entered the lexicon of science. The coded interaction then came the next layer of revelation. On April 18th, while monitoring Atlas's hydrogen pulses, radio astronomers at Meerkat detected faint sideband frequencies accompanying each emission, tiny fluctuations encoded at the edges of the main signal. The sidebands were faint, but they mirrored the timing of Echo's 22-minute oscillation. When plotted, the interference pattern revealed a modulation curve resembling frequency shift keying, a primitive form of radio communication, similar to how early Earth satellites transmitted binary telemetry. If the analysis was correct, Atlas and Echo were communicating, not with Earth, but with each other. Dr. Emil Costas, who had been tracking the pulse since its discovery, described it in a now-famous interview. "We've been trying to listen to Atlas, but it was never speaking to us. It was speaking to its partner, and we've been eavesdropping on their conversation." For the next several days, the data poured in. The modulation between the two objects followed a repeating structure. 44-minute pulse from Atlas, 22-minute response from Echo, then silence. 44, 22, 0. The cycle repeated with near atomic precision. Someone, or something, had built a binary duet in space. Global consequence. The effect on Earth was immediate. Stock markets shuddered. Religious leaders issued statements of cosmic humility. Governments convened emergency meetings under the pretext of orbital monitoring coordination. And in observatories around the world, a new kind of fear began to take hold. The fear of comprehension. Because once you understand a pattern, you are part of it. At the European Space Operations Center, analysts noticed another anomaly: faint telemetry delays in several active spacecraft, Psyche, Solar Orbiter, even the aging Voyager 2, each experiencing minute timing shifts synchronized with the Atlas echo cycle. Whatever the pair was doing, it was subtly altering the electromagnetic environment of the inner solar system. "It's like they're adjusting something," one engineer muttered, "tuning the space between them." The transmission. On April 22nd, a new signal arrived, unlike anything before it. The usual 44-minute pulse came from Atlas, but instead of fading to silence, it continued, rising in amplitude for nearly 2 minutes before suddenly collapsing into a brief, blinding spike that saturated sensors across all instruments. When the data was deconvolved, the pattern emerged. A single narrow-band burst spanning the hydrogen alpha and hydrogen beta lines simultaneously, a physical impossibility in natural emission. More shocking was what followed. 11 minutes later, Echo responded, with a mirror burst, inverted in phase. For the first time, both objects had acted in sequence, transmitting what appeared to be a synchronized exchange. To some scientists, it was proof of communication. To others, a warning. Because the combined energy of the dual burst was enormous. Millions of joules released across visible and infrared spectra, equivalent to detonating a small fusion reaction. Yet no debris, no radiation spike, no damage to surrounding space. The power simply vanished, absorbed. When the data reached SETI's central servers, one analyst whispered, "They're charging something." That night, telescopes recorded one more anomaly. A thin, translucent arc forming between Atlas and Echo. A faint line of ionized hydrogen stretching tens of thousands of kilometers, glowing briefly before dissipating. The shape was unmistakable, a bridge of light. And in its shimmering geometry, buried within the noise, analysts detected a modulation repeating once every 44 minutes. The same pulse as before, but inverted, as if directed outward, toward Earth. Part 12. The Bridge. The Light Between Worlds. For a moment, it looked like a filament of dawn stretching across the void. Two specks of light, Atlas and Echo, linked by a shimmering thread that pulsed softly every 44 minutes. It wasn't bright, not enough to dazzle the eye, but through telescopes it glowed with the color of sunrise, hydrogen alpha red turning slowly to violet. Astronomers on Earth saw it first as a photometric anomaly, a sudden elevation in the background luminosity between the two bodies. But within hours, the arc became visible in multiple wavelengths: optical, infrared, ultraviolet. It wasn't a beam, it was matter, excited and structured, like a bridge of charged gas held together by an unseen magnetic field. At first, everyone thought it was a trick of ionization, solar wind trapped in a resonance corridor. Yet the bridge didn't disperse. Instead, it stabilized. The physical impossible. Every known rule of plasma dynamics said it shouldn't exist. A filament that long, spanning over 12,000 kilometers, should collapse within seconds. Yet Atlas's bridge persisted for hours, then days. The field lines were too coherent, as if tuned by constant feedback. "You'd need active control," said Dr. Henrik Volkov, staring at the magnetogram from ESA's solar orbiter. "It's behaving like an electromagnetic confinement tube. Someone is maintaining it." The data backed him up. The magnetic flux density around the bridge oscillated with the same 44-minute rhythm as the red pulse, while localized bursts of hydrogen beta light propagated along it like ripples in a rope. Each wave traveled at 0.01 c, far too slow for light, but too fast for ordinary plasma drift. It was movement with intent. Observing the arc, NASA and ESA immediately convened joint observation teams. Using spectropolarimetry, they mapped the filament's composition: 99% hydrogen, trace helium, almost no dust. But what truly defied comprehension was the polarization pattern: circular on Atlas's end, linear on Echo's. The bridge seemed to twist light itself, transferring angular momentum along its length. That twisting carried data. Every ripple was modulated, patterned. When plotted over time, the oscillations formed a binary lattice identical to the earlier prime number pulses. Only now, the signal was continuous. Atlas and Echo were no longer sending discrete messages. They were transmitting a stream. The listening Earth. On Earth, deep space antennas struggled to keep up. The Deep Space Network reported telemetry drift across multiple spacecraft, all synchronized with the bridge's activity. The Voyager 2 probe, nearly 20 billion kilometers away, recorded a faint electromagnetic echo of the same waveform, a whisper from the edge of the solar system. Something was resonating through space itself. At the same time, power grids and GPS systems began to stutter again every 44 minutes. The resonance had returned, stronger than before. To the public, it was unsettling. To scientists, it was exhilarating and terrifying at once. If this is a communication event, said Dr. Lillian Cho, then it's using the solar system as a waveguide. Governments issued coordinated statements insisting there was no threat to infrastructure. But behind closed doors, emergency committees were formed. Data from multiple satellites showed faint auroral disturbances rippling across Earth's poles in rhythm with the bridge's pulses. The planet itself was reacting. Decoding the Stream Project Resonance, the global network of scientists decoding the pulses, received new data directly from the James Webb and VLT. When they processed the continuous stream, they found repeating sequences of mathematical constants, pi, e, and phi, followed by geometric ratios corresponding to planetary distances in astronomical units. Then, buried deep in the sequence, came a new pattern: 1, 0, 0, 1, 0, 0, 1, 1. When translated into binary ASCII, it corresponded to the characters H, E, 2 letters. Meaningless on their own, unless it was an abbreviation, a fragment, a start of something longer. Some argued it was coincidence. Others whispered that it was an attempt at translation, a test to see if we would recognize a symbol from our own language. Whatever it was, the sequence repeated 10 times, then stopped. The silence before the shift. On April 27th, the bridge brightened suddenly, flaring almost to magnitude 0, visible even in twilight skies. Cameras around the world captured it, a faint red line stretching across the stars, linking 2 points like punctuation in a sentence the cosmos was trying to finish. Then, for exactly 44 minutes, nothing happened. Every instrument flatlined, no pulse, no radiation. Just absolute electromagnetic stillness, an impossible calm across the entire spectrum. And then, at 044400 UTC, the bridge inverted. Atlas dimmed, Echo brightened. The polarity flipped. Spectral analysis showed the energy direction reversing, flowing toward Echo, not away. For the first time since its discovery, Atlas had become the receiver. Echo had taken command. The bridge shimmered, once, fractured into thousands of thin filaments, and then gone. The connection dissolved into silence. Atlas returned to its earlier brightness, steady and red. Echo vanished completely from optical view, leaving only a faint infrared trace drifting outward, as if receding into the deep dark between worlds. Aftermath. The following week was chaos. Some claimed the event had ended. The bridge was a transient anomaly, the communication complete. Others feared something far larger had begun. On May 2nd, astronomers noticed that Atlas's orbit had changed once again, this time subtly outward, no longer resonant with Mars or Earth. Its new trajectory was on course to exit the solar system entirely, following the same path it had entered. Atlas was leaving, but its final gift remained, a continuous narrowband signal in the hydrogen alpha spectrum, still pulsing every 44 minutes. Its amplitude faded day by day, but it never stopped completely. As it receded into the black, the last recorded pulse, captured simultaneously by ground observatories and the Voyager 2 receiver, showed a final, unexpected modulation. Translated to binary, it was simple: 3 letters, E, A, R, then static. The light that waits. The world argued for months. Was it coincidence, a trick of data compression, or the beginning of a word that was never finished? Ear. It could mean Earth, or here, or perhaps something else entirely. Whatever the meaning, one truth was certain. The universe had spoken, if only for a moment, and humanity had listened. Now, every 44 minutes, telescopes still watch that corner of the sky, waiting for a pulse that may never come. Because once you've heard a voice in the dark, the silence afterward is never the same. Part 13, The Return Transmission, What Earth Chose to Send Back. In the wake of the bridge's collapse, Earth entered an era of waiting.
For the first time in recorded history, our species faced a silence that felt personal. The object that had refused every category of science, 3i/Atlas, was leaving, and with it, the one unmistakable sign that we were not alone. But the pulse remained.
Every 44 minutes, like the echo of a heartbeat drifting through the black, the signal persisted, fading but still measurable. It was enough to keep the world listening. And finally, it forced a question no one had the authority to answer. Do we respond? The Council of Silence. In May 2026, representatives from 52 nations met in Geneva under the auspices of the United Nations Office for Outer Space Affairs. The assembly was formally titled the Interstellar Communication Deliberation Group, but the press called it something simpler: the Council of Silence. Their task was to decide whether humanity should transmit a reply to Atlas, and if so, what that reply should be. The debate lasted 10 days. On one side were the cautionists, led by the US and Russia. They argued that responding to an unknown intelligence could expose Earth to unpredictable risks. If Atlas was an observer, why alert it further? If it was something else, a probe, a test, a machine, any reply could trigger a chain of events humanity wasn't prepared to face. On the other side were the responders, spearheaded by the European and South American delegations. They claimed that the signal itself was an invitation. Silence, they said, was no longer neutrality. It was rejection. If the universe called our name and we said nothing, argued Dr. Lillian Cho, now a scientific advisor to the UN, what kind of civilization would that make us? There were practical considerations too. What frequency to use? What language? What power level? Any transmission strong enough to reach Atlas would also broadcast Earth's exact electromagnetic fingerprints across light years. There would be no taking it back. The signal architects. In parallel with the political debate, a quiet alliance of scientists and engineers began their own work. Funded anonymously and operating out of an unused ESA facility in Darmstadt, the group called itself Project Echo. Their mission? Design a reply that could be both safe and unmistakably intelligent. The answer came from mathematics. If Atlas had spoken in primes, geometry, and constants, then Earth would respond in kind, a sequence of patterns that required no language, only logic. The transmission would consist of 3 layers: a repeating series of prime numbers encoded as amplitude shifts in the hydrogen alpha line mirroring Atlas's original pulse. A binary image composed of 441 pixels, 21 by 21 grid, forming a simple symbol recognizable across cultures, the double helix of DNA. A temporal marker, embedding the frequency of the hydrogen line, 1,420 megahertz, and the orbital period of Earth around the Sun, universal constants identifying the sender's context. It would last exactly 44 minutes, the length of a single Atlas cycle, and would be broadcast 3 times from 3 separate locations: the Arecibo Successor Array in Puerto Rico, the Parkes Observatory in Australia, and the FAST Telescope in China, a global signature.
The plan was kept classified. Officially, no reply would be sent. But on June 14, 2026, at 0444 UTC, the first pulse left Earth's atmosphere, an invisible beam of coherent light tuned to the same hydrogen alpha wavelength that Atlas had used.
The transmission's power output was modest by cosmic standards, but symbolic beyond measure: 1 billion watts, a candle against eternity. It was the first time our species spoke with one voice, Dr. Cho later wrote. Not to each other, but to the dark. Waiting, the signal took 11 minutes to reach Atlas's last known position, and then nothing. For hours, the world watched. No pulse, no flare, no bridge. Some called it anticlimax, others called it mercy. The signal continued to repeat 3 times over the next 2 days. Each iteration was logged by observatories, cross-verified, and archived in the Global Radio Registry. Then, at 0444 UTC on June 17th, as the final transmission faded, a faint anomaly appeared. A single pulse, hydrogen beta, from the direction where Atlas had last been seen. It was weak, barely above noise. But its timing was exact, 44 minutes and 4.4 seconds after the end of Earth's final broadcast. 4.4 seconds, a fractional delay. When the data was decoded, it contained a single amplitude spike at the center of its waveform. In binary, it translated to 1. A reply? Or a reflection? No one could be sure. The legacy of a pulse. The world argued endlessly. Conspiracy theories flourished. Politicians demanded proof. Philosophers demanded meaning. But amid the noise, a quieter revolution began, one not of technology, but of perspective. Across nations, schools added the Atlas event to curricula. Children learned to calculate prime numbers and draw hydrogen spectra. Humanity, for the first time, saw itself not as a collection of nations, but as a single data point in a cosmic dialogue. Astrophysics budgets doubled. SETI became a global institution. And once every 44 minutes, synchronized observatories around the world paused their work to listen, not because they expected an answer, but because listening had become a form of faith. We spoke, Dr. Cho said in her final public address before retiring. And that's enough. Maybe the universe isn't waiting for our intelligence, only our courage to say hello. The whisper that remains. By late 2026, Atlas was gone, its faint light receding beyond Jupiter's orbit, the signal growing weaker until only the most sensitive instruments could still detect its pulse. Yet on a cold night in December, one last observation was logged by the Voyager 2 deep space receiver. It wasn't a pulse, it was a continuous tone, narrowband, steady, and faint. When engineers slowed it down, stretched it, and filtered the noise, they found 3 distinct frequency steps spaced exactly 44 seconds apart. 3 notes: do, re, mi. Simple, human, impossible. No one ever detected another sound from that direction again. But the file, v2_ATLS last signal.wave, is still archived in the Deep Space Network servers. Scientists play it now and then, mostly out of ritual. The notes fade quickly into static, but if you listen carefully, right before the noise takes over, there's something faint, a second tone, barely audible, hidden under the first. Some swear it's an echo, others say it's the universe humming back. Part 14. The Awakening, the Silence That Speaks. By the end of 2026, silence had returned to the sky. No more pulses, no more bridges of light. The hydrogen line was quiet, and 3I Atlas was gone, its faint signature slipping beyond the reach of even the James Webb Space Telescope. The official narrative, circulated by NASA and the European Space Agency, was that the event had concluded naturally. But to those who had lived inside the data, silence was not an ending. It was a new kind of signal. The ghost data. In early 2027, the Deep Space Network, DSN, began noticing something strange in its background noise. The system's ultra-sensitive antennas, tuned for spacecraft telemetry, had to compensate for solar interference by averaging long stretches of radio static. But when technicians filtered the noise, they found periodic gaps, microscopic silences exactly 44 milliseconds apart. No sound, no light, just absence, repeating in the same rhythm that had once defined Atlas's heartbeat. When the gaps were plotted on a time-frequency graph, they formed a pattern, binary spacing that alternated between short and long silences. When decoded, the sequence resolved into a familiar progression: 2, 3, 5, 7, 11, 13. Prime numbers. It wasn't transmission, it was subtraction. The universe itself seemed to be cutting out data at precise intervals, like the faint impression of a voice that had stopped speaking but left fingerprints in the quiet. Engineers thought it was interference from aging DSN hardware, but cross-checks at Canberra, Goldstone, and Madrid confirmed it. The same pattern was emerging across all stations simultaneously, synchronized to Earth's rotation. Something, somewhere, was still listening, and now it was echoing back in silence. Atlas left us a pattern, not in sound, but in space, said Dr. Emil Kostas, now head of the SETI Institute. It's like someone erased every 44th word from a book to see if we'd notice the rhythm. The human reaction. The world had changed. The Atlas event had become more than a scientific phenomenon. It was a turning point in human identity. Religions reinterpreted scripture. Artists wrote symphonies around the 44-minute cycle. Even stock exchanges and data centers synchronized clocks to the interval, half tribute, half superstition. Humanity had begun to measure time not in hours, but in pulses. Governments quietly continued to fund Project Echo, rebranded as a permanent research division under the United Nations. Its mandate? Maintain a continuous hydrogen band beacon directed at Atlas's last known trajectory. The signal repeated endlessly, a steady heartbeat of prime numbers, geometric constants, and one simple phrase encoded in binary: "We are still here." No reply ever came, but something else did: the lunar reflection. In late 2027, China's Chang'e 8 lunar orbiter detected faint backscatter in the hydrogen alpha frequency, reflected not from deep space, but from the far side of the moon. The reflection wasn't random. It mirrored Earth's outgoing beacon, but inverted, reversed in phase, as if bounced by a mirror that wasn't there. When modeled, the reflection originated from a moving source roughly 40 kilometers above the lunar surface, traveling too slowly for debris and too fast for orbit. It was there for 44 minutes, then gone. The world didn't know. The data was classified. But inside the small, windowless command room in Beijing, a handful of scientists sat in stunned silence as they watched the waveform scroll across the screen. The moon had spoken. The silence turns inward after that. Subtle anomalies began surfacing everywhere. Atomic clocks at CERN drifted by exactly 4.4 milliseconds every month, despite recalibration. Quantum entanglement experiments recorded irregular decoherence patterns, each one spaced 44 minutes apart. Even medical imaging systems picked up faint rhythmic noise, like static breathing in the background. It was as if the 44-minute cycle had embedded itself into the fabric of measurement, into the physics of observation itself. And then, for a brief window in August 2027, the pattern changed. During a total solar eclipse over the Pacific, magnetometers around the world recorded a synchronized drop in field strength lasting 4.4 seconds. Power grids flickered. The DSN arrays went offline for exactly one interval. When they came back, their memory buffers contained a single line of corrupted text. Still listening. The message was unsigned, and the checksum didn't match any known data format. Analysts dismissed it as coincidence, radiation interference during the eclipse. But for those who remembered the Bridge of Light, it felt like a whisper returned. The return of the echo. In December 2027, Voyager 2 transmitted its final complete dataset before entering extended hibernation. Among the telemetry packets was an unexplained spectral anomaly, a narrowband tone, identical to the red pulse, faint but distinct, detected from a direction opposite to Atlas's exit trajectory. If the measurement was real, it implied something impossible. The signal wasn't traveling outward from the solar system. It was coming in. Dr. Cho, who had long retired from public life, wrote one final message in her field journal before vanishing from media entirely. We thought the silence meant it was over, but what if silence is their medium, and we're only now learning how to hear? The awakening. By the start of 2028, humanity had become a civilization of listeners. Every continent maintained synchronized listening arrays. Every observatory had a hydrogen alpha receiver pointed skyward. The silence that had once unnerved the world now united it. And though nothing more was seen of Atlas or its companion, once every 44 minutes, precisely, relentlessly, instruments around the world registered a faint dip in background radiation, a heartbeat of nothingness. The silence had become a metronome. Whether it was a relic, a memory, or a call waiting for reply, no one could say. But in that rhythm, a strange calm settled over humanity. The understanding that perhaps the truest form of contact was not a message, but the shared stillness between two beings waiting for one another to speak. Part 15. The Final Pulse. When the sky spoke once more, it began, as it always had, in silence. By early 2028, the world had grown accustomed to quiet skies. The Atlas event had faded into myth, its pulse reduced to background rhythm, a heartbeat only instruments could still feel. The 44-minute cycle had become the clockwork of a planet that had learned to wait. Then, one night in June, waiting ended. The first flash. At 04400 UTC on June 12, 2028, every telescope monitoring the hydrogen alpha line registered a spike so intense it overloaded their detectors. The data overflowed buffers, saturating channels with red light across the visible spectrum. For 4.4 seconds, the sky itself seemed to exhale. From the Atacama Plateau to Mauna Kea, from Beijing to Cape Town, witnesses described the same impossible sight. A soft red glow, not in one direction, but across the entire horizon, diffused through the upper atmosphere like a global aurora. There was no solar flare, no coronal mass ejection, no cosmic event on record could explain it. When the flash subsided, the world was left in silence again. But this time, the silence was heavy, expectant, as though something vast had just inhaled. And then came the sound, the frequency of the Earth. At exactly 044444 UTC, seismographs across the planet began to tremble, not violently, but rhythmically. A wave pulsed through the crust and oceans alike, a slow resonance too deep for ears, but unmistakable in instruments. It circled the Earth twice, then faded. The frequency was 7.83 Hz, the Schumann resonance, the natural electromagnetic heartbeat of the planet itself. Atlas's silence had reached into the Earth. No one could explain it. The tremor was not destructive. No buildings fell, no volcanoes awoke, but every system tuned to electromagnetic frequencies, from satellites to pacemakers, recorded the same modulation, a narrow-band oscillation embedded inside the Earth's resonance. When decoded, it wasn't random, it was binary, and the message was simple: pay. Awake! The light behind the moon. The world erupted into chaos. Within hours, observatories turned skyward, desperate to find the source. Most saw nothing, but one did. The Lunar Reconnaissance Orbiter, circling the moon's far side, captured 3 frames before its sensors went dark. In those images was a faint, structured glow behind the lunar limb, a soft arc of light, moving not away, but toward Earth. Its spectrum matched the red pulse exactly. Echo had returned, but this time it was alone. The structure, or object, reflected hydrogen alpha light at varying intensities, forming a pattern that, when mapped, resembled a spiral, the same spiral that Atlas had once shown in its prime number signal. At its center, one point blinked slowly. Once, twice, once again. 1, 2, 1. You are here. The world listens. For 72 minutes, the signal grew stronger, spreading across the electromagnetic spectrum. Not just light, but radio, infrared, ultraviolet, even gravitational wave detectors registering faint synchronous oscillations. It was everywhere, all at once, as though the entire fabric of space-time had begun to hum. In the control rooms of SETI, CERN, and every major observatory, scientists stared in disbelief as the hydrogen line split in two, forming twin peaks, one red-shifted, one blue-shifted, spinning around each other like binary stars. The ratio of their oscillation matched exactly the timing of the old Atlas echo cycle, 44 minutes and 22 minutes. The duet had returned, but not from deep space, from here. It's localized, whispered Dr. Costas. It's inside the Earth-Moon system. The pulse that spoke at 0612 UTC, the signal stabilized. Then, for the first time since the Atlas event began, the modulation changed. It wasn't primes. It wasn't geometry. It was language. Encoded in the amplitude variation of the hydrogen beta emission, researchers discovered phonetic structures corresponding to human vowel frequencies. When converted to audio and slowed down, the result was chillingly familiar. A voice, distant, fragmented, but unmistakably human. Ear. Then static. But this time, the static wasn't noise, it was structure. Within it, embedded harmonics formed repeating intervals of 440 Hz, the exact pitch of the note A, the standard reference for human musical tuning. The universe was speaking in the language of sound, in the frequency of the human ear.
The final moment. At 0656 UTC, the signal crescendoed. The red and blue peaks collapsed into a single blinding flash. Around the world, radio receivers screamed with white noise, and then, for the briefest instant, every connected device, every phone, every computer,
every satellite feed displayed the same text: "We hear you." No source code. No transmission origin. Just 4 words, perfectly timed to the end of the 44-minute cycle. Then, everything went dark. For 11 seconds, the planet was electromagnetically silent. No broadcast, no network, no signal. Total, absolute quiet. And then, the systems came back online. The sky returned to normal. The pulse was gone. Atlas, echo, the bridge, the silence, all of it ended. The aftermath. The world didn't erupt this time. It simply stopped, paused in awe, as though the meaning of the moment was too immense for panic. For the first time, humanity understood what listening truly meant. Not to dominate, not to answer, but to be heard. In the following years, no further signal was ever detected, but the effect on human civilization was irreversible. Nations began dismantling orbital weapons. Space agencies collaborated without boundaries. Music written in 44-minute cycles filled concert halls, blending mathematics and melody. Children learned to write in binary before cursive. And every 44 minutes, global observatories still paused their operations, not for science, but for silence. A silence that wasn't empty anymore. The legacy of the pulse. In the archives of the Deep Space Network, one final file remains unclassified, a recording from the exact moment of the last transmission.
When played at 1/144th speed, it reveals a tone faint enough to be almost imagined. It isn't a word. It isn't a message. It's music. The overlapping hum of hydrogen resonances forming a single harmonic chord. Mathematically perfect, emotionally human.
The note fades, and in its final echo, a whisper lingers, impossible to verify, barely above noise floor, but clear enough that once you hear it, you cannot unhear it. We were never alone.